Hello everyone, I hope you can all hear me and that you're all settled. I want to welcome you today to our webinar, A New Way to Visualize Your Designs in Fusion 360. This is the third webinar in our A360 rendering webinar series. My name is Allison Guerin-Klein and I'm on the product marketing team for rendering in A360. Our webinar today is hosted by John Hutchinson, the Chief Visualization Platform Architect of A360 Cloud Rendering here at Autodesk. Today, before we get started, just going to give you a little bio about John. John has over 15 years of experience as a software architect, engineer, and manager at Autodesk. And as Chief Visualization Architect, he defines the strategies for cloud rendering and ensures execution of cloud-based visualization. So before we get started, a few things about today's session. The webinar is scheduled for 1 hour and we'll save 10 to 15 minutes at the end for a Q&A session. If you have questions at any point during the webinar, you can type them into this box here and we'll try our best to answer them at the end during the Q&A session. If we don't get to them at the end, we'll make sure to follow up through email. You can write to us at rendering.community@autodesk.com. The webinar is also being recorded and we'll be sending you a link to the video within 48 hours. And then before we get started, we just wanted to ask you a few quick questions via poll. So I'm going to launch that right now and they'll show up briefly on your screen and you can select your answer and it should only take a couple of minutes. Giving you a few more seconds here to finish voting. Okay, and then we're going to move on to the next question. Okay, and last question. All right, thanks everyone. Now I'm going to turn it over to our presenter, John Hutchinson.
Afternoon, everybody. So as Ali said, I'm John Hutchinson. I'm an architect here at Autodesk, and I've been working on visualization tools in various forms for the last 18 years. I started on the 3ds Max team around the first release on Windows. Today, the main topic is going to be the interactive rendering tool. Are you guys seeing my screen?
Not yet.
Okay. Let me fix that. How about now?
Yep, we can see it now.
Okay. So today I'm going to be talking about the interactive rendering tool, which is accessed through A360. This is currently a beta offering. It's a companion tool to the cloud rendering offering. And I'm going to be working on this bike model. So I just wanted to acknowledge the folks that provided the models. So let me go to Fusion Gallery for a second. So Jeff Hooper, who runs Backhand BMX bikes, he's been doing lots of work in the Fusion Gallery around designing bike parts. He provided the bike model. I'm also going to use a model that I harvested from GrabCAD, and I just want to call that out. So this is the iWatch model. Whoops. I think it's called Apple Watch. So just thanks to Michael Christensen, who did a very quick and fast job, nice job of making the Apple Watch. And lastly, I'm probably going to quickly show this earbuds model because it shows off when you would want to use translucent materials and how those are integrated into Fusion. So the interactive rendering tool is a beta offering. It's currently only accessible for Fusion models through A360. Our roadmap is to open that up to all the data that's in A360. But since we're currently constrained to Fusion, we're going to start with a little bit of setup in the Fusion product. So I'm looking at Jeff's backend bike model. And I'm just going to close the data panel. We'll come back to that in a bit. And in Fusion, I can navigate my model through named views. I'm going to now set this up to do some visualization. So I'm going to maybe create this shot, and I'll just name these. Kind of boringly, I'm going to make an overall shot. I'll zoom in on the seat. Make a view here. And let me focus on the stem. And maybe I'll do something like this for the stem shot. Now, mostly what I want to show you occurs in Fusion's render workspace. So let me, I'm already in the render workspace. So let me get the materials browser open. And I'm just going to make a couple of changes to the materials in here. So I'm going to find weathered rubber. I'm going to apply that to tire. So the weathered rubber has a roughness map, so you can see there's a little variation in the reflectance of that. I'm going to find a plastic, and I'm going to pick a textured plastic. I'm going to use this polka dot on the pedals. You can see as I applied that now there's a bump map. It's starting to give the effect of an injection molded plastic part that would have some kind of height profile on it. And then lastly, I wanted to make kind of an intentional mistake here. Let me find leather, and maybe I'll try this perforated red leather. All right. So for visualization, obviously assigning materials is an important step. Setting up texture mapping on your objects in Fusion is also important. I'll admit that that's probably the weakest area in Fusion right now for visualization, but it's also an active area of development. So look for new stuff there in the near future. I do want to show a couple of new features within Fusion. So if you're not familiar, you can specify one of several pre-canned IBL lighting environments. I'm just going to leave that as it is with the plaza environment. It gives kind of a blue hue. I can decide if the environment creates the background color, or I can choose a constant color. I'll leave it at the environment. And then I can turn on ground reflections and ground shadows. In this model, it's not going to matter, the ground reflections, because I actually have a geometric ground plane that I'll use. So just a quick review there, really. I'm going to turn on local ray tracing, and I'm just going to put this into the quick mode. So now we can start to see ray trace shadows on the concrete wall behind. The reason I turned this on was to show you some of the new camera settings. So I can now adjust the focal length of my camera. And with ray tracing enabled, I can turn on depth of field. So to set the focal plane, I click with this tool active, and then I can adjust the overall blur. So that's a new addition in Fusion recently. So let me turn ray tracing off. And just to review, we created several named views in Fusion. We made some material assignments, and we looked quickly at the local ray tracer. Now, the local ray tracer is awesome if you have a powerful machine. Let me just to drive that point home, I'll run Task Manager for a sec. And if we look at my cores on my 12-core box and turn ray tracing on, bad things happen. Well, good things for rendering engineers, bad things for users. So I have a 12-core machine here. All of my cores are now pegged. My application becomes hard to use. If I'm in advanced mode, it will converge at a decent rate, but fairly slowly. So if you have a powerful machine, use local ray tracing. It's great. The algorithm is quite a nice path tracer. But if you're either not a user of Fusion or you happen to be needing to do visualization from desktop or mobile, this is not going to work. So let's pivot over to cloud rendering services then. So I'll disable this. I'm just going to save this quickly. And actually, before we go to cloud rendering, I just want to look at one other model to showcase some new material features that were recently added. Okay, so this is the Apple Watch model, which I borrowed. And my main point in borrowing it was to test some new emissive materials that we added to the renderer. So what I want to show is if I isolate this sensor on the back, and if I turn off the lens, what we're left with is a tiny LED. It's a ½ millimeter square. And if I go look at the material that's on it, it's this one. And I adjusted this based on one of the new emissive materials. So let me find the presets for emissive. Where are they? Okay, so here's the emissive category, and really these are intended as starting points for making things that emit light into the scene. And there's kind of an assortment of typical bulbs. There's a number of displays, and what's really important to get right is the brightness of these materials, because both the local renderer and the cloud renderer are really, they're based on simulation of the physics, and so they care what the units and the brightness of these objects are. So if I scroll down here, I think I started with this green LED, and then I adjusted its brightness to something very bright. And so this is 1,000 candela per meter squared. So you need bright stuff if it has a very small area, and that matches with Intuition. The other one, which was, let me unisolate that now. And let me go back to this view, and we want to look at the case. Here we go. So let me isolate the case and the LED display, the OLED display. And I'll turn off the glass face. And what we're left with is just an emissive quad here. I used one of the canned display presets, and then I harvested an image to simulate the emissive display on the Apple Watch. So check out the Emissive Materials, the new Emissive Materials. That said, let's now pivot over to cloud rendering. So the way that you access that currently is through the data panel. If I go to a model, and we're going to go look at the bike, I say open details in A360. And that brings up the item details page. And what many people don't know is that because Fusion stores all of its data in the cloud, what we can do as the data changes is automatically generate renderings. So all of the named views, which are stored in my Fusion file, get generated into photorealistic renderings. So the way that contrasts to local rendering is, whereas if you're rendering locally, you have to use your own compute resources. Your machine is tied up for the duration of the rendering. In the cloud, you can get much better performance and much better throughput. So if I examine these renderings, they're pretty large. They're 2 megapixels, and this one took 14 minutes to complete. Some of these other ones, which are the draft renderings, render really quickly, so 23 seconds for these various views. So why might that be useful? We're really trying to drive the visualization workflow away from a single user working in a complex app like Fusion, and letting other people who are involved in the collaborative design process get involved in visualization. So one immediate thing that I can do, if either I'm a different persona, so I'm not a Fusion user, I'm a marketing person or a project manager, I can look at these renderings and kind of assess where this design is in the process. As the design matures, maybe I want to start giving feedback to the designers, or I can even start to do a little bit of rendering myself. So this is where we get into the interactive rendering mode. So from an existing rendering, just going to start with this shot, I can launch the interactive rendering tool. And as I said, this is currently in beta. So it pops out into a separate window, which is not a perfect experience, but will certainly get better. And basically what happens is I've created a session that's running in the cloud now, and does server-side ray tracing to let me play with this model. So, for example, I've already set up some specific shots in here. So there's my stem shot. This is my sprocket shot. I don't have a seat shot in here. I'll explain why in a few minutes, but let me just quickly make one. So I can now navigate in this environment, and if I don't get lost, find my bike seat, compose a shot, and let me just replicate what I did in Fusion. What's happened with those changes is there's currently some load on the system, so those new renderings aren't ready yet. So let me just search for leather here, and I'll find the white perforated leather, and I'll put it on the seat. So this is running another path trace engine, but instead of consuming my local resources, this is running in the cloud. So I can make that point by just bringing up perfmon again. And notice there's really nothing going on my machine other than the browser's running. So where was my session? There we go. Okay, so I assigned white leather. I'm going to say later that I don't like that. I'm going to come back down to the pedals, and all of the materials that we saw in Fusion are also available in the interactive rendering tool. So let me search for a textured plastic here, and again, here's the polka dot that I applied in Fusion. I'll reapply that here. And then going back to the stem, that looks like a bug. Get back to the stem. And I'm going to find anodized, and I'm going to put aluminum anodized onto the stem.
Sorry about that. I think we lost John's audio. Just a second here while we get that figured out.
Am I back?
Yes, now we can hear you.
I leaned on the mute button. I do apologize. Okay, so I was adjusting depth of field. Again, I can adjust the field of view. But the point of this tool is not to use this interactive canvas. Obviously, there's some compromises made between interactivity and quality, and the way this works is we use the same renderer to generate samples on the cloud side, and then we stream it to your browser as a movie. So to keep that fairly responsive, we compromise some quality. That too will be getting quite a bit better in the near future. But the point of this is that I can compose a new shot, and now I can render it offline using the normal default renderer. So I have a few choices here about quality, and I can pick an aspect ratio, I can pick the overall size of the image, and when I'm happy with that, then I can click render and it goes into my queue and will show up back in my rendering carousel. Okay, so let me close this session. And come back to my details tab and refresh it. Okay, so now we're back looking at the bike. While I was working in the interactive rendering, those jobs that I had submitted previously completed. So this was the overall shot that I made called Render 1. This is the seat shot that I created. And you can see here's the brown perforated leather. And finally, the stem shot. I actually operated on a version 2 rendering. So I made those changes in the interactive rendering here, and I submitted a new job here, which is still in queue. So this one now has the blue anodize that I applied, and that's resolving now. This is the preview frame for that shot. Okay, so coming back to this version, to summarize, as I change my data in Fusion, because Fusion's underlying model is stored in the cloud, we can recognize when you check in new versions, and we currently generate renderings of all the named views that are in the file. We're soon to release a better way of managing those views that allows you to set up a folder of shots that you want to keep synchronized to the major revisions of the file. I also showed that from any of these automatically generated renderings or any other renderings that are stored in the cloud, I can pretty easily go into an interactive rendering mode to tweak them. I'll just do that quickly just to drive the point home. So from a rendering, I can launch this interactive session. It re-enlivens the data, runs the renderer on the cloud using other people's compute resources. That keeps my machine free, and it also means that I can do this from a mobile device. And then in this environment, I can assign materials. So maybe I prefer the black perforated. I can do basic operations on my shot, so I can adjust the exposure. I can apply depth of field. I set the focal plane with a double click. I can create and set up different view angles. And I can render new jobs using the cloud renderer. Okay, so I'll kill that session. I'll refresh here. Requires a forcible refresh at the moment. And actually, to talk about the sharing workflow, let me pop over to a different model. Let me say a couple things about this earbud design, even though we didn't have too much time to look at it. So I showed you the emissive materials. The other relatively new material type is the translucent material. So we're simulating a translucent plastic here. While it's an opaque material, there is a considerable amount of subsurface scattering that happens. So this is an example of the type of result you get from that. Once the renderings are in the cloud service, there's a set of operations we can do on these. So for one thing, I can re-render these at different resolution, which may be useful if I'm going to print or need to do other types of presentation. For fusion models, I can render them as turntables, and I'll show you what a turntable result looks like in a minute. It's just kind of a semi-interactive way of looking at the model. I can always download the backing images. What we're showing here is actually downsampled, so the full-size image may be quite a bit larger than what gets displayed. Whoops, that's download. I wanted to show a few other adjustment tools. So for example, I can make fine-tuning to the exposure after the fact, which is just kind of handy. Let me pop over to the Apple Watch. And if I go to the renderings tab for the Apple Watch, I'll just show you what oh, by the way, we didn't see this, but the result of those emissive materials are results like this. So that green emissive LED is behind a lens, so you get a subtle effect of light coming through. And on the face, having the display be modeled as an emissive material makes the display really pop. I guess I need to go back to an earlier version to look at the turntables. Okay, so this is a turntable rendering I made of the watch. Essentially, you just tell it what resolution, what angular resolution you want to create, and it makes you a little interactive movie. Similarly, in the cloud renderer, you can generate motion study animations, and for architectural users, the cloud lets you generate solar studies, and soon we'll support walkthroughs as well. So here's a better still shot showing the LEDs leaking through. All right, so this data is in my A360 project. Anyone who's working on the project has access to these renderings and can generate new ones and comment on them. But I may get to a point with my design that I want to start telling my story externally. So that's where the sharing workflow comes in. So from the item details card, I can share my renderings to existing or new project. I've already shared some of these, so I'll just update this one. And let me just say I'm adding this, and I'll publish it. And then I can go to the Fusion gallery, and this is what is presented to the public. So it shows all the renderings that I've generated, which I've chosen to share out to the community. I thought this one had the turntable, but it doesn't, but you can just as easily share those turntables into the Fusion gallery. Okay, I'm going to stop there for questions. I'm hoping that I can actually sneak in a quick peek at some new features in Dev. So I'm going to shut down Fusion and start the Dev environment while we take questions.
Okay, great. Thanks, John. We have a couple questions here. One is, will the controls for ambient occlusion, photon bounces, etc., be available in the near future?
So, so those are, that sounds like a rendering expert like me. We're trying to make the visualization workflow easier and more accessible to a larger audience. In the past, we've exposed a lot of the internal controls of the renderer. So photon mapping is one technique for approximating the bounces of light. We actually don't use photon mapping in either of the rendering technologies. Both technologies are closer to a path tracer, but when we run in the cloud, we do something like photon mapping, which is that we start the light sources to distribute energy, whereas when you run locally, we do really a path tracer from the camera perspective. But we're trying not to expose that kind of complexity of the renderer. We'd like the experience to be that you use the local renderer for evaluating materials and setting up your visualization, and then you use the cloud renderer for generating absolutely the best shot. And so we hope that you don't need to worry about that complexity. Now, to your other question about ambient occlusion, that's a technique that we use when we're in the product, when we're not ray tracing, and I believe you can control that. I'll double check in a minute when I get into Fusion again.
Okay, great. And then there was another question, was that is the refined mesh that you used in the earbud a standard material?
Which one? Ah, yes. So, yeah, that's a cool one. So there's a metal mesh here. This is just one of the standard, this is steel with small holes. Yes, it is one of the standard ones. However, I did adjust the scale of those holes to make it fine. So I can show you how to do that maybe in a minute. I forgot to, I wanted to show this shot, which is actually the shot that Jeff Hooper made of his bike. And we were getting there during the demo, but I was really happy with the fact that Jeff was able to get this kind of result using the interactive renderer. Any other questions?
Yes, there's one. Can you utilize the walk-around render elsewhere, for example, on a web page?
Yes. So you can play back the turntables in our web environment, like I showed you. You can also download those as either a self-contained HTML file that you can host on your own site, or you can download the raw images, and if you're nerdy, you can program it and use a whole bunch of different tools for displaying that. But yeah, we let you download it as a self-contained HTML file.
Great. And then there's one more, which was, can you share using a private URL rather than in the gallery?
Yes, you can, although it's security by obscurity. So I can show you that. Let me just get Fusion going. So now I'm into the rendering dev environment, and I'll show you a couple new features here, but what I'm looking for is a turntable rendering or a panorama. Okay, this is slightly off topic, but this is a so-called stereoscopic panorama. Generally, it's the architecture folks who want to produce these. These views they're both spherical projections generated from perspective of a left eye and a right eye. For all of our asset types, we let you generate a semi-private URL. And we're just working on this feature. I don't think this is going to succeed. But that's how you can create a URL that you can share with colleagues. It is not password protected currently. We want to add that as a future enhancement. Okay, if I can get through Fusion's dialog. So disclaimer, this is the Fusion development environment. And I want to show you just a couple of things. So let me open a model. Actually, should probably open Jeff's model. Okay, well that struggles a little. Let me show you the other new feature I wanted to show you. So here is a rendering of a brake lever. Again, I owe thanks to somebody who's actually good at doing mechanical design. If I open this up in the interactive renderer in the development environment, there's a couple of new features I wanted to show. All right, so I'm back in my interactive ray tracer. Let me set up a shot. And let's say I want to work on this anodized aluminum. In fact, the guy who was designing this part ended up branding this this brake lever as the pinky lever, because I guess you can pull it with your pinky. So it gets into kind of precise color control. So if I just use the default materials, I can get a red anodized aluminum. Let me brighten this up to make the point a little better. So I'll increase the exposure and add a little depth of field. Set this as the focal point and orbit around. Okay, so that's slightly pinkish, but if I actually care about a brand color. I really need precise color control. So this is the new feature. It's our color workflow. Integrated into the interactive renderer is all the Pantone color books. So I'm going to go to the solid uncoded colors, and I'll just search in here for pinks. The results get listed in the Pantone color book sequence, and I want this thing to be a little bit garish. So I come down here, and now I think I missed on the drop. So notice that the hue of the pink is now changing to match this virtual pink, and we've been pretty careful to make sure that the colors are all linearized going into the renderer. So you get pretty predictive results as you use your Pantone colors in here. So that's how you could end up with a nice pinky lever for marketing materials. And then when you actually go to fab this, you can say, yeah, I'm using Pantone 181856. Okay, so that's the new feature in the interactive renderer. Let's see if Fusion has come to life. And it has a bit. All right, so this is another motorcycle part. And as we saw earlier, I can invoke the local renderer, but to get to the cloud renderer, I had this sort of awkward pivot through the item details to get to 360. So in the upcoming release of Fusion, that's considerably better in that all of my cloud renderers are now immediately available in the Fusion canvas. And there's a render cloud button right here in Fusion. So I could, for example, set up a new shot on this part. Change my materials. Sure. That's actually a translucent material, so to correctly appreciate it, I have to turn on the ray tracer, and to really appreciate it, I have to put the ray tracer in its kind of heavy-duty mode, which is advanced mode. And I can use the local ray tracer to preview that, but I probably don't want to let that fully refine here because it's burning up my 12 cores. I can't do any other work. So I can just fire that off to the cloud, and defaults to final quality. It defaults to the exact screen resolution that I'm looking at. I can also go pick other preset sizes, but I'll leave it at screen resolution, and I'll fire that off, and then I can go on with my other work. It shows up now in the carousel, and soon I'll have full resolution, well-refined rendering with my local changes. And like I said, it's the dev environment, so this is the quick exit feature. And I'll go ahead and send the CER. So those were the new features I wanted to show you. The integration for, well, all those features will be available in the February release of Fusion. So any other questions come up in the meantime?
Yeah, there was one here. Can you show how to render with invisible background alpha channel?
Sure. To do that, let me find a model that's appropriate. There's lots of stereo panos in here. Oh, I'm having a hard time finding something. Here we go. This will make the point, although it's not the prettiest model in the world. So the question is, how can I generate an alpha channel for my rendered image so that I can do my own compositing in Photoshop against some other background? The way you do that is just from an existing render, I can re-render. I choose PNG or TIFF as the output type. I recommend PNG because TIFF is kind of old school. And then I turn on the alpha transparency background option. What that does is it creates a separate channel that has the alpha information in it. So when I take it into Photoshop, I can composite using that as a mask. Other questions?
Yeah, so there was one, is there any way to get a quicker rendering response in the interactive renderer, like any settings?
During beta, we are trying to solicit feedback on what the most important features are without using too many resources. So currently we run on, we use 3 computers for every session that's running an interactive renderer. I think for now it's going to probably stay that way for a little longer, but we definitely want the response to be much snappier. The other thing we're changing about the interactive renderer is currently it only refines to a pretty coarse rendering. We're going to allow that to just refine arbitrarily fairly soon. If you write to me or write to the rendering forum and complain about the performance, you'll probably twist my arm into putting more resources on it. It's very easy for us to add more computers. It just increases our costs.
Gotcha. And then one last question, which is, what are the fees for using the rendering system?
So the interactive rendering service is currently free while it's in beta, but it won't be free forever because we run several, in addition to the normal computers that we run on the cloud, we're running a front-end GPU that's generating the video stream, and we share that across multiple sessions, so it's not too much more. But the backing rendering does cost money, and if you've tried to build your own render farm, you know that. So when we're rendering in the cloud, we're usually using multiple machines, and it's a hybrid infrastructure that runs both on Autodesk data centers as well as in Amazon cloud. So at any given moment, we're running hundreds up to thousands of machines for this service. So the way that we charge for it is using cloud credits. So let me just, if I re-render this image, any rendering up to a megapixel in size is free, so it requires no cloud credits. When I go to final render quality, the cost is then based on the number of megapixels that you're asking, and this is actually a conservative estimate. We only charge you for what you actually use. Rendering is a little bit hard to estimate a priori how many resources it's going to use, but this rendering of a very large 4K by 2.6K image at final quality would cost you 11 cloud credits. Cloud credits are provided to users either through, generally through a subscription, and at different levels of subscription, you get different allocations of cloud credits. Once you exhaust those, you can buy more, and the rate is roughly $1 per cloud credit, but that's subject to change downward. Of course, compute gets cheaper every year. Unfortunately, the complexity of models that we throw at the renderer increase at kind of the same rate, so cost seems to be kind of constant, but generally we expect compute to get very, very cheap.
Great, thanks, John. I think that's all the questions we have.
Cool. Thanks all.
Thanks. So thank you for a great presentation, and let me just share my screen here so you can see a couple other resources. So yeah, thanks again for attending, everyone. If you'd like to check out some of our websites, we have a rendering website here at autodesk360.com/rendering. You can also check out the Fusion website at fusion360.autodesk.com. And we'll follow up with these email links and more helpful links to our forums, videos, all that in an email with the recording of the webinar. And if you have any other questions, just email us at rendering.community@autodesk.com. And like John said, we're interested in getting your feedback about what features you'd like to see added to the renderer. So after we close the webinar, there'll be a brief survey. So if you'd like to write your comments in there, please do. And thanks once again, and we'll see you next time.